Well, welcome to Universal CPE and Virtual Network Functions Explained, our 20th monthly webinar on the FreeSBC Pro SBC series, covering technical, business, and partner topics to help service providers and enterprises better secure their voice networks. This month, we explore the future of new network services and how Universal CPE, or uCPE, is used by service providers to combine many separate fixed function network elements with a single multifunction device. Using virtualized network function software, or VNFs, on a Universal CPE, providers have a consistent and flexible foundation they can build on to offer new SD-WAN, SIP trunking, and other services for providing network security with SBCs and firewall VNFs. During today's session, the experts from Telco Systems will be joining us to explain how Universal CPE equipment and VNFs work together, offering a competitive edge for service providers and their customers. So let's get started. First, some introductions. I'm Alan Percy. I'm the Chief Marketing Officer for TelcoBridges and today's event moderator. Joining us also today from his offices in Northern Israel is Gabi Podolsky. I'm sorry, Gabi, if I got that wrong. He's the product line manager for Telco Systems, and Gabi joined the company about 3 years ago and is responsible for their NFV Time OS and their Telco Universal CPE Manager products. So Gabi, thanks for sharing your expertise today.
Thank you, Alan. Thank you for having me with the audience.
Great. All right, a quick look at today's agenda. We've covered the introductions. We're going to spend just a couple of minutes talking about the complicated network closet and everything that's going on back in that closet, and kind of a funny little story. And then we're going to move on to explaining what it is network function virtualization and virtual network functions. It's a mouthful. Why Universal CPE, some market analyst perspective, and then we'll get into some use cases, and we'll wrap up with where to learn more, and certainly answer your questions as we go along. So just a couple of slides from me to get things started, and I thought I'd do is just give kind of the basics of what is Universal CPE and VNFs Explained, and Gabi's going to get into much more detail during his portion of the presentation. But before we do that, just I noticed that there are quite a few new faces on the webinar today. I just wanted to quick introduce our company, TelcoBridges. We're a manufacturer of media gateways and session border controllers and other equipment. Company's privately held, founded in 2002 with about 35 employees. We're headquartered just outside Montreal on the South Shore. And we have most of our development and production in that particular facility, with sales and support in offices in Poland, Turkey, and Hong Kong. And of course, I'm based outside of Buffalo, running marketing, and proud to be part of this really great team. And Gabi, do you want to introduce Telco Systems?
Yes, thank you.
Oops.
Telco Systems is a network equipment vendor that has been around for many years, as long as we have the telco.com website, so you can imagine. We have customers all around the world, and traditionally we made carrier equipment for MPLS, for carrier Ethernet, and in the last 3 years we've been doing NFV, in particular Universal CPE. Thank you.
Good, very good. All right, so just yesterday we were starting to get the slides wrapped up, and we were talking about the problem statement, and as sure almost every business, a retail outlet or small business you look into, if you find a room someplace in the back of the building, if you open the door, you see something that looks like this, which is a combination of some kind of network termination router. In this case, it probably is a DOCSIS router, or I'm sorry, DOCSIS modem. Then some kind of router, you see the Cisco device, and then maybe some switching equipment, and then cables and wires, and probably a power strip, and maybe a UPS, and all this is tucked away in the back of the closet in the room. And one of the problems with this, of course, is the level of management and integrating all these pieces together. installing them, and then they're fixed function. They do what they do, but they don't do anything more than they do. And that's really one of the problems that service providers are facing, is there's this collection in the back of the room. But then during our chat yesterday, we were talking, Gabby and I were talking about, as he calls it, the vacuum cleaner problem, which, Gabby, if you just quick summarize the story, I think it's kind of funny.
Sure. Back in the day, we had a bunch of servers, and in the evening, a person came with a vacuum cleaner, and he couldn't pass from here to there, and he disconnected the cable. The vacuum cleaner came back, connect the cable back. That was our whole internet connection. So we lost internet for 5 minutes. That happens all the time. So I called that the vacuum cleaner test, and I asked to do that in our software quality assurance program.
Yeah.
But that happens. So when you have 3 different types of equipment, each one with its cable, then you have this problem multiplied by 3.
Yeah, yeah. So it's easy for this collection of equipment to somehow, I guess, not only suffer maybe a power outage, but also, curious hands. Oh, I can just plug in something here, and they don't know what they're doing. So anyway, that's the problem. Another thing that's an interesting part of the discussion is the shift from the core to the edge. There was a rush during the early days of the cloud to push everything they could to the core, put as little as they possibly could at the edge of the network, at the customer premise, and have this all in the core, have it all centrally managed, have it all virtualized. But what they discovered is that the customers have been saying, you know what? There's some things I really still want at the edge of the network. I still want my firewall at the edge of the network. If there's some survivability, maybe a SIP proxy. If there's maybe some other function that is that the organization is highly dependent on, this stuff still needs to be out at the customer premise and give that point of demarcation for the service provider too, so that they can do testing, for example, at that point. And the pendulum is really swung from, instead of everything going in the core, to suddenly realizing that putting some things at the edge of the network has some value. And Gabby's going to talk about that in his slides in a little bit more detail when we get into it. So one of the things that was an outcrop of that move towards virtualization in the cloud was some work that that Etsy was developing. Basically packaging together a virtualization strategy that included 3 key components. And we're going to talk about these components today. Starting at the bottom left with this network function virtualization infrastructure, right? This is, at the bottom is the hardware, the compute, storage, and network, and some virtualization software, but also compute and storage and network virtualization. Then at the top are these virtual network functions, or VNFs, that are software modules or individual elements that would make up a network infrastructure. We'll go through some examples in a couple of slides, but you can imagine they could be firewall, and they could be routing functions, and these things. And at the right is this management and orchestration layer, which helps manage the interface or the routes of the traffic through the lower layers, and which VNFs are activated, and how many instances there are of those various VNFs, and manage the overall platform. And this was initially designed, from everything I can tell, to be at the core of the network. And what we're going to talk about today is how this same architecture is being deployed out at the edge of the network. At the same time was an innovation called Universal CPE. And this is from the hardware manufacturing part of the industry, bringing together some new platforms that are processor, memory, and collections of network interfaces, along with the usual storage, I/O, power supply, and wireless infrastructure, to create a single device that could provide the functionality for these branch offices, for branch banks, retail outlets, any of these situations where you need to combine this functionality that previously was done with multiple devices, compress it down into a single package, reducing not only the footprint, but power usage, and simplifying the installation and implementation. These platforms, however, in their simplest form is we call them white boxes, right? It's just the hardware. It's the processor, memory, network interfaces, etc. in a box. There's no software at all on these devices except maybe a bootloader, USB bootloader. So they're very, very simple. And here's a couple of examples of them. The Lanner 2510 and the Vantech 1012 are very popular platforms. So the question comes then is how can you mix these together? And this is where the beauty of what we're going to be talking about today is how it all works, which is you bring that ETSI architecture and you apply it to this blank piece of hardware that can go out at the edge of the network, and you can implement these layers of the network function virtualization and bring these VNFs out to the remote device. So now a service provider or a large enterprise can put a single box out at the edge of the network, and they can push software images, these virtualized network functions, out to that edge. So in this example here, a copy of our Pro SBC session border controller software is a VNF. This example I also show here a Fortinet VNF, and then there's some, there's many others that are out there, and we'll talk about some of those as we go along here. And then they all need to be managed, right? The virtualization layer and then the orchestration. And this is the role that that Telco Systems brings to the platform. So how do these all interact? Well, one of the key things is this idea of service function chaining, that you can build stacks of these VNFs and these software modules together to create a virtual version of that stack of appliances that were in the back closet. You can do switching, you can do routing and SD-WAN, session border controller, firewall. You can put applications, either voice or data applications out of there, and of course an entire layer of management software. Bringing this all together and creating a virtualized version of that closet that we saw at the very, very beginning. What are some of these VNFs that are popular? Probably the most popular one today in the market is SD-WAN VNFs. They're driving a lot of the innovation in this space. Probably right behind it then is firewall. We're seeing session border controllers get pushed to the edge of the network, certainly routing, application delivery controller, and occasionally we see some media services getting pushed to the edge of the network. And some of the analyst reports, just taking a peek at what some of the analysts are saying, one of them was, what are some of the top VNF use cases? Where is this getting used and deployed? And by far the most common is this enterprise and SMB gateway. It's as we talked about, the branch office, the retail outlet, these kinds of situations. Leveraging Universal CPE and SD-WAN is one of the first things. We're also seeing it used heavily in service chaining applications, right? Eliminating those separate boxes as we showed. It's also appearing in the mobile core with pushing the IMS architecture. We're seeing content delivery networks, right? Pushing some of the content closer to the consumers of the content, speeding up delivery in cable networks and other platforms. And we're also running into this, the mobile radio access networks, these RANs being based on VNFs sitting in, dedicated equipment out at the edge of the network. IDC weighs in on this on the network function virtualization market, and their most recent report quotes that they believe the telecom VNF market to grow to about $16 billion by in 2022 with a CAGR of 45%. That's a huge explosive growth, and a lot of what's driving that is this SD-WAN innovation and a lot of this combination that you're seeing along with pushing voice applications out on the network. Another analyst, IHS Markit, also talks about the Universal CPE equipment, and they see this increasing from 7 million 2 years ago to 1 billion by 2022. This is a huge explosive growth over 6 years. So this is a tremendous opportunity for the hardware manufacturers too, and a huge transition. So who's actually doing all this? Well, we know AT&T is hot on the trail with their AT&T Flexware. They've built they've combined many of the network functions into a single device that they're delivering to the marketplace. They've been very active with it. They had their big partner conference, 2 weeks ago, I think it was. And this was a big topic of the conversation at that conference. And also Verizon just recently announced a relationship with Lanner to deliver their managed services on a VNF environment for their Verizon Enterprise Services. They call it the Verizon Virtual Network Services capability. And this is, again, delivering WAN optimization and SD-WAN functions to large enterprises for their branch offices. So with that, I'm going to turn it over to Gabby and him dig a little deeper into what's going on behind the scenes. So go ahead, Gabby.
Thank you. So we are doing NFV for, I don't know, 5 years, maybe more. Used to be a time in which people believed that they can take any network function and made it virtual, running on a data center, and just put a simple switch at the customer prem. It works for core functions because they're already there, but it doesn't work for many other applications. Many IT managers will tell you, no, the firewall has to be here in the customer premises, or WAN optimization has no meaning when you're already in the data center. And SD-WAN, the leading application in today's network, it's all about localizing, steering, optimizing when you are at the edge. That's why the idea of having a NFV only in the data center can only be partially true. The other problem is that if you don't have cloud computing expertise within your team, you need to grow, you need to teach everybody a new working paradigm. Your operations have to change dramatically. While if you are going to have something like Universal CPE, it's much more closer to your existing router or firewall. It looks like it, and it's deployed much more similar. And you don't have to make an important investment in a data center. That's the other side of, going back to the pendulum to the other side. But there are a mix of both models, which is a distributed model in which a lot of the DNFs are in the customer premise in a Universal CPE, but you're going to chain them to some other VNFs which are in the data center. So perhaps the main security point is in the customer prem, but the antivirus or part of it is in the data center, or some media caching is going to be in a point of presence, which is a small data center, etc.
Yeah, and in fact, one thing you pointed out when we were talking earlier was about the desire of the customers. There's things that they had to have on their customer premise, and I think you mentioned firewall was one example. Did you have another example or two else?
Then the things that you guys made, the SBC.
Yeah, the SBC.
Some people, in some cases, they put it in data center, and in many other cases, and I have an example showing when and how. The SBC is also because it's protecting the calls.
Right.
There is a slide later showing exactly where and when the SBC sits on a customer prem.
Right.
All right. So why people thought about making Universal CPE, and then we are going to say what is it. So you have 1, 2, 3, 4 boxes. So you have your SD-WAN, your firewall, and your SBC. Each one is a box. And instead of that, you want to virtualize them and put them on a single box. Single set of cables, single power, single physical maintenance, and that's it. So that's the whole idea about virtualization, and in particular about using uCPE. So go to the next one. a lot of people talk about uCPE today, but then what is it? So we've been receiving requirements from customers in different engagements and in RFIs. And our conclusion is that a Universal CPE has two phases. First is a networking device, because it's the first entry point into the enterprise branch. And then it's a virtualization device. It has to boot and connect to the network before it can be the host of virtualized network functions. So it has a lot of the characteristics, physical and software-wise, of any router or switch. And then it has all the characteristics of a compute node that you see in a cloud computing environment. And if we look at the beast on the face, you see in front of you this box. It looks like a switch or a router or some equipment that is for network processing. But inside is a computer. It has a motherboard with an Intel or ARM chip, a bank of memory, and an SSD disk, and that's it. There is no specialized equipment. I could use this as a media center at home. And the different characteristics are things like you need routing, you need LTE, Wi-Fi. It has to be manageable via netconf and CLI. You need to do all the software monitoring, all the hardware monitoring, all the strict security. And then you have to do zero-touch provisioning, because the idea is to send these boxes to a customer prem and only connect to power and network, and this has to be installed on itself. Download the configuration from a central location and install on itself. No complex installation process. But in order to do that, you need some intelligent orchestrator, which we call the uCPE manager, that is able to do the configuration and the zero-touch provisioning and all the monitoring. And once it's up and running, then the NFV happens. And then you have to handle all the concepts of having hypervisor and all the special acceleration technologies, PPDK, SRAOV, and we in our case are using OpenStack to manage the virtualization. And at that point, when it is already up and running, it will automatically deploy the VNF that you prepare for this particular customer. So magic will happen, the virtual machines are going to be created, and in a matter of minutes, you are going to have a service with an SD-WAN, a firewall, and an SBC. Okay. Next. So some of the use cases, going from small to big, if you have an SMB, it's possible that a service provider will construct a virtualized pack with just a firewall and a router, or maybe just a firewall, and brand it on its own name. If you're having to more of a medium business, you're going to start caring about optimizing your MPLS lines and using WAN optimization, perhaps also using SD-WAN with all the intelligent steering. For a large enterprise, certainly you're going to use today SD-WAN, probably also SBC, because you have lots of zip lines, trunking, and perhaps also a unified communication that is virtualized. On the other hand, if you are managing a campus, you're going to be very interested in content filtering and also unified communication across the different labs and classrooms, etc. Go on, please.
Okay.
So I looked at a couple of typical UCP service topologies, which are not different from any other networking topology. We just looked at them in the eyes of the UCP today. Assuming that there are two possible type of networks, the expensive ones and the cheap ones. So if you need to transmit high bandwidth applications, and you need to ensure that the traffic is going, then you're going to buy an access service over an MPLS or current internet network. But on the other hand, there are broadband networks. They are not so reliable, but they are substantially cheap. And that's where SD-WAN came to do the interesting traffic steering, and they can decide, an enterprise can decide to pass the file transfer over MPLS and the part of the voice over broadband, all the web browsing and all your Facebook and over broadband, and you're paying 10% of what you're paying on the MPLS line. So you're having SD-WAN in each branch, SD-WAN in the headquarters. You may have a firewall on each branch, but then you will place, because this is a hub and spoke topology, you will place your SBC only in the headquarters, assuming that the phone lines only come to that location. In the more of a mesh topology, each branch is independent. Imagine you have some enterprise that it has a few branches, but each of them is relatively large, and they are far away. Then each one is going to have the same VNFs, like the SBC is going to be in each one of them, because they are connected to a different local telephony provider. But yet they are communicated between each other, so they still need to transmit over MPLS and broadband. Go on, please.
Okay, next.
Yes. So people ask the question, why customers want a UCP? Our sales directors ask me, why people want this UCP? So first of all, people believe in the separation between software and hardware. Telecom operators, they like the idea that they can buy the hardware, the white boxes, directly from the white box vendor, and they can mix and match vendors. They can change it at any time. And the same about the VNF. They can have service flexibility. They can innovate. They can have two SD-WAN vendors without testing the hardware. Can two firewall vendors, separate one for one optimization. They can add a virtual SBC. They can add probes. They can invent the wheel and put their own application as far as they can put it in a virtual machine. So that's the beauty about NFV, and in particular in a UCP. The UCP also is a soft entry into an NFV. It's an invest as you grow model. It's CFO friendly. There is short time to service, because you can start very quickly deploying UCP services on customers, and you can expand it later when you are ready into a more NFV distributed model if you want to put also VNFs on a data center. And there are particular things that you can only learn from customers when you talk to them. Logistics. For global operators, for global managed service providers, you learn that logistics is a big deal. And then you can have many local warehouses and distributors. You can reduce shipping time. Reducing shipping time, you're reducing your mean time to repair or your mean time to install. this gives you an advantage as a service provider. Taxes, in some places, perhaps not in the US, but in other places, there are heavy taxes on hardware. But if you ship generic hardware, or if you buy hardware made on that country, and making a universal CPE is way easier than making specialized router, because it's, as we said, it has a few ports, but inside is a computer. So taxes have a lot of meaning in many places. And then homologation, and things like a safety level, rugged devices. Imagine that you have a service and you need 3 network functions that you're going to buy from 3 different vendors. Each of them have to homologate. Each of them has to do safety tests. Each of them have to make their own plus 50, minus 50 degrees test. But instead of that, you buy one uCPE from one vendor, and the other 3 vendors are going to give you just software. So everybody is saving a lot in time and money.
Great. Okay.
Next. So now a bit about us, Telco Systems, NFV time. So our offering starts from the NFV time OS. That's our operating system that has networking and virtualization. And we can work over any white box. We don't have to do a complex porting process. We come with a USB drive, or we pass the software to the white box vendor, and they do the pre-installation, and it just works. So that's the NFV time OS that is running the VNFs in the customer prem. We also have a bundle that we call the Verge, in cases that the operator or the managed service provider, they want us to be the single point to choke. Then we take the responsibility to bundle the white box, the NFV time OS, and even the VNF. And then we have the UCPE management and orchestrator that we call the UCP manager, that is going to do the whole traditional FCAPs and the NFVO for the VNFs running on these UCPs.
Right.
Next.
Good. Well, thanks, Gabby. That was great content. We got a couple more slides here, and then we'll get to the Q&A here. But one big piece of news that we wanted to share today is that this morning, TelcoBridges issued a press release about our hardware validation program. And this idea of this program, with a little bit of background on this, we've had customers come to us with our Pro SBC and Free SBC offering and said, this is great, but what hardware should I run this on, or how should I deploy this? And so we decided to just, let's validate some combinations of hardware and software together and do some performance testing, and then publish this in a validated hardware program. And so we formally launched that program this morning and did this press release. And Telco Systems is part of this announcement with their NFV time software, helping us deliver these virtualized network functions on some of the white box platforms. And specifically, we tested the platform from Lanner, their NCA 2510, with the Telco Systems NFV time, and we validated up to 4,000 sessions with RTP processing and 300 calls per second, which is plenty for almost any enterprise application and large, large branch application. So this is quite a bit of bang for the buck. Our test, the test people fell in love with the Telco Systems NFV time and the Lanner box combination, and was one of our first platforms that we did validation on. So, and there's a URL at the bottom there if you want to see some of the specifics. There's much more on the actual configuration and environment. So we wanted to announce that, and that's how Telco Systems and TelcoBridges came together. It was delivering this platform together. Some other news is we're headed to the Metro Ethernet Forum, or MEF, as they like to be called, in Los Angeles in November. I would, if you happen to be in the neighborhood and would like to get together, I'd love to meet with any of you, or maybe one of your representatives. I've got set up a Calendly page here, the URL, and of course there'll be in the follow-up email that you can see. You can check on availability and book a time slot, and Gabby's going to be there too, and you can set up a time separately with Gabby using his email address. So we're looking forward to meeting with some folks face to face, and a lot of the program at MEF is about this concept of the intelligence going to the edge of the network, Universal CPE, a lot of the platforms. There's quite a few vendors there with VNFs and other elements, so it's kind of the meeting point for a lot of this conceptual work that's being done. And we wanted to wrap up too with some more information about our ProSBC platform. We have a free edition, the freesbc.com. You can go there and click on the pricing page to download a free copy of it. We have all the frequently asked questions from past events on the forums, and lots of other educational content, including the previous recorded webinars on our YouTube channel at YouTube/TelcoBridges. And I want to encourage you to subscribe to that too. We're trying very hard to hit a milestone with the subscribers, and would appreciate a click there. That would help us, and then that way you'll be notified when new recordings are being published. The recording of this event is being published. From that functionality. So let's move on to some Q&A. So let's see. I got one quick question here from Randy. And one slide mentioned DPDK and SRIOV, and can explain. Please explain. I'm not exactly sure which slide that was.
Yes, I do. In the one which explained what is a UCPE. Okay. At the beginning of cloud computing, people use just simple applications, and they never imagined that they wanted to virtualize network functions. But any network function has a forwarding card. Okay. So what do you do when you have to pass really fast packets from a physical port to a virtual NIC? If you do it through the main processor and the main memory, this is going to be very slow. So that's why smart people invented other technologies. One of them is called DPDK. That was invented by Intel. So you put a process that is all the time, the only thing it's doing is copying packets from the physical port to the virtual NIC, the physical port of the white box device to the virtual port of the VNS in the virtual machine. It's a bit like DMA. If folks have been around enough, they remember how DMA changed the way in which we copy data from the disk to the memory. It's a similar concept. So that's DPDK. SRIOV is a similar thing. It's just pure hardware. DPDK requires a dedicated core. In our case, we have done ways to use half a core, sharing the core with the operating system. And SRIOV, as I said, is a pure hardware mechanism to do the same.
Right. And matter of fact, just to add to that, DPDK is the mechanism that our SBC uses to shuttle packets around, the media packets from point A to point B. It is one of the requirements for using both FreeSBC and ProSBC. That's how we get some of the performance figures. And without it, Gabby, as you mentioned, we would come nowhere near that kind of performance. If we had to copy them to memory and then push them out another port. So one other question, actually I had, Gabby, is we talked a little bit about the offering from Telco Systems is software and then the bundled platform, but it is still a little confusing as to how does someone get a platform? They buy just the software from Telco Systems, or can they buy a bundled software, software platform with
that's what we call the Verge. They can buy a bundle from us, and we take care of purchasing and installing and shipping the white boxes from Lerner, Advantech, whoever it is, and we take care of even the putting some logo for the service provider on top, anything that has to be done. So that's one way, and the other way is that I've seen in really large tier ones that they want to handle their own purchasing of these white boxes, and they only get from us the OS license and the UCPE manager license.
Right. And of course, our VNF could be part of that bundled solution.
It could be as well. If somebody also wants us to take the responsibility to sell them the VNF, if it is an SD-WAN or an SPC or something else, of course.
Yep. Good. All right. Well, one last call for questions. If you've got a question, feel free to pop it in the Q&A panel there. Otherwise, and also to Gabby, let me just open up real quick. So there's probably some news coming, hopefully at the MEF event, or some recent news.
We are going to announce our 100 gigabit per second carrier Ethernet switch, which we call the 8104. And that's on the traditional side of the house, the carrier Ethernet. And also, we are going to talk about a recent achievement that we arrived together with Intel, and we were able to take one of the white boxes and get close to 40 gigabit per second performance. So we had this announcement to Intel in the latest Layer 1 to 3 NFP conference in Hague. And we created a white paper together explaining how you get to that, what type of performance you can get, which is very much taking us out of the enterprise uCPE and into the multi-access edge computing and 5G, when you can arrive to this type of performance.
Yeah, no, that's pretty impressive. And myself and Mark Sanange will be at the event. We'll be sharing additional information about what we're doing with our hardware validation program and talking with some partners there. So look forward to having some meetings there. So it looks like that's it. There's no additional questions. So I, first of all, Gabby, want to thank you for sharing some of the content, and appreciate all the expertise you brought to the table.
Thank you for the invite.
Yep. And then, as I mentioned earlier, as a live event participant, we'll be shooting out an email with links, and I do want to remind you to forward the links to the recordings along to anyone who might find it useful, and make sure you click on that subscribe and then on the bell on the recording over on YouTube. We look forward to having you as a subscriber, and hope to have you on a future event. And that's it from here. So have a great day. Thanks for listening. I hope you found this content useful. And don't forget to share this with any other your coworkers or others who might be interested. Also, don't forget to click on subscribe, and there's links below.